Okay, let's look at derivatives of log functions, right? So if you take the derivative of natural log of x, what you get is 1 over x, right? And so this is for natural log, but if you have a general log, so for example base b, log to the base b of x, if you take the derivative of that, you will get this. Remember that we have a change of base formula. We can always rewrite log function in a different base. This is equivalent to natural log of x over natural log of b. All right, so this is equivalent to taking a derivative of natural log of x over natural log of b. But the natural log of b is just a constant, so 1 over natural log of b is constant. Then you just have to take the derivative of natural log of x, which just learned that it's 1 over x. So what you get is 1 over, right? So it's a natural log of b is just a constant, so I'll just put that on the bottom. Then times x, right? All right, let's look at an example. This example contains both, all right? So we want to find the derivative of y equals negative natural log to the base 2 of x, sorry, I said natural log, log to the base 2 of x plus 10 times natural log of x. All right, let's find the derivative. This is going to be y prime is going to be equal to, so there's a negative sign there, right? So it's going to be 1 over, right? Base is 2, so we have natural log of 2 on the bottom and x on the bottom, right? Plus, right? 10 is just a constant, so I'll just put it upstairs, right? Derivative of natural log of x is 1 over x, so it's going to be 10 over x, right? So this is the derivative of the function here. All right, another example, this is a typical tangent line problem. Let's try to find an equation of the tangent line to the graph of f of x at the x equals e. All right, so as usual, we need to find two pieces of information, and first one is a point. All right, let's call it x1 comma y1. All right, then x value is given, so x value is e. All right, then you have if you plug in e for x, so f of e is going to be, right, e comma, so f of e, so natural log of e is 1, and you can put 3 in front. So this is actually, remember that if you have a power here, you can always put it in front. So we can rewrite this function as 3 times natural log of x, right? So if you plug in e into that, 3 times natural log of e is 1, so it's going to be 3 here. Oops, I'm supposed to use blue. All right, 3 here. All right, and how about the slope? All right, as usual, we're going to use a lowercase m, can be found by taking the derivative of the function and plugging the x1 value, which is e. Right? All right, to do that, we need to know the derivative. So derivative is going to be, all right, let's look at this guy and take the derivative. 3 is a constant multiple, so I just put it upstairs. And derivative of natural log of x is 1 over x, so it's going to be 3 over x. Right? So plug in e, you will get the 3 over e. All right. by point slope form again, we can find the equation. So from here, we can find the equation y minus y1 is 3 is equal to m is 3 over e times quantity x minus e. Right? We can simplify this a little further. So I'm going to distribute 3 over e to x and 3 over e to negative e. So you will get 3 over e x, and 3 over e times negative e would be e cancel out, so it's going to be negative 3. Alright. Then you can see that here there's negative 3 on the left and a negative 3 on the right, so you can cancel that by adding 3 to both sides. So you get equation y is equal to, so y is equal to 3 over e x, right? So this is an equation of the tangent line that we are looking for. All right, that's it. I hope that this was clear.